Welcome to Aerospace Engineering Study Program. I'm going to introduce you to our lab and show you some equipment that we use. Aerodynamics Lab is a facility to support research and lectures activities related to aerodynamics for aerospace or non-aerospace applications. You may find Aerodynamics Lab in Lab Tech 2, ground floor, or hangar. In Aerodynamics Lab, we study complex fluid phenomena and apply our method to analyze and design aerospace bodies. At Aerodynamics Lab, we work on cutting-edge design, analysis, and optimization in the field of aerodynamics through experimental and computational techniques. Here, we also hold practicum for courses in instrumentations, measurements, and experimentations, or IME, and experimental aerodynamics. Throughout the years, many research have been conducted here in this lab, such as experimental fluid mechanics. In this lab, we conduct research on the advanced experimental fluid dynamics problems and the development of our own advanced experimental tools. We also conduct research on design optimization with machine learning. This research deals with design optimization and explorations of engineering problems using machine learning and statistical learning algorithms. In the field of computational aeroscience, the research lies at the intersection of fluid mechanics and solid mechanics to obtain a mathematical model for a complex system and to develop a numerical method for the solution of a model. This lab has some equipment and tools such as closed-loop subsonic wind tunnel, water tank, open-loop subsonic wind tunnel, high-powered laser, and high-speed camera. Now, let's take a brief look at some of the tools and activities we have in the Aerodynamics Lab. Before we start, please make sure that you follow all safety procedures. Here, we have closed-loop subsonic wind tunnel. This is our closed-loop wind tunnel used for aero research purposes and practicum. This tool is a grant from TU Delft, and in 2020, it received several additional instrumentation systems. It is equipped with force balance for force measurements and pressure sensor to view pressure distributions. In investigating the phenomena, we also use a method called particle image velocimetry, or PIV. Our laboratory also has a water tunnel that can be used as a flow measurements, both quantitative and qualitative. A common flow measurements apparatus, for example, particle image velocimetry and load balance, can be installed in the water tunnel. Water is used as the medium fluid that will interact with an object test. We are at Light Structure Facility, and it is located in PAU building, the 3rd floor. At the Light Structures Laboratory, we work on design, analysis, and optimization of lightweight structures. In this facility, we are conducting several research related to crushworthiness, blastworthiness, and battery protection. The Light Structure Laboratory has 3 main tools: tensile testing equipment, fatigue test equipment, impact testing equipment. Let's have a look at some of the equipment here. Drop weight machine is a tool used to determine the strength of the structure when subjected to impact loads. In an impact test using this equipment, the specimen is placed and held at the bottom part of the equipment, and then an object or load will be pulled up above the specimen until a particular height, and then released. This load will fall down and hit the specimen to give an impact load to the specimen. we have fatigue testing machine. This tool is used to test resistance of a material when subjected to repeated loading. Fatigue testing is commonly used in damage tolerance research. Before periodic maintenance is needed to avoid fatal structural damage in the future. This is a vibration and control laboratory located in Lab Tech 2, hangar, ground floor. At the vibration and control laboratory, we work on design, analysis, and optimization in the fields of vibration and aeroelasticity, and also some aspect of system dynamics and control. In general, we have done some research, including aeroelastic system modeling and analysis, dynamic system modeling and simulation, control system development. This laboratory is not only used for research but also used for lecture, such as practical introduction to flight measurement sensor, basic electronics and data acquisition system simulation for instrumentation, and measurement and experiment or IPE. Vibration and Control Lab has several main tools, namely Aeroelasticity Wind Tunnel, Flight Measurement Sensor. Aeroelasticity Wind Tunnel is an open-loop wind tunnel that is used for observing and investigating aeroelastic phenomena. Aeroelasticity describes interaction between flexible structure and unsteady aerodynamic load that works over the structure. This phenomena may occur in aerospace applications, such as in aircraft, and also in civil structures, such as high-rise building and long-span bridge. In this lab, we also deal with instrumentation related to flight dynamics field. Here is our new air data test system. This is used for simulating and testing sensors that work based on air pressure that commonly used in aircraft. This equipment can also provide students with understanding about the work principle of aircraft sensors. This is Flight Simulation Room, which is located in Lab Tech 2, the 4th floor. In the Flight Simulation Room, we do simulations and analysis related to simulation on flying vehicles. The aim is to obtain some data related to the flying parameters of the selected flying vehicles with various conditions set during the simulation. In this lab, we not only do some research but also lectures such as the introduction of the flight measurement sensor for the instrumentations, measurements and experiment or IPE course. This is our flight simulation system. It is developed to simulate the dynamic response of air vehicles during its flight. Using the simulators, we can simulate some aircrafts with their particular characteristics, get the flight data, and then process them for other purposes, such as for determining the aerodynamic coefficient of the aircraft and for building the dynamic model of the aircraft needed for flight control development.